Hello, friend, and welcome to Sleep Science 360. Let yourself arrive slowly, as if the night has been waiting for you. In the distance of deep time, supernovas are opening like giant flowers of light, releasing everything they were back into the universe. Even the brightest endings become part of the quiet again. You can sense the room settling around you, and that's completely okay. You breathe softly, and the universe exhales through you. Your breath lowers, your body softens, and the world grows quieter. And now, as the calm deepens, the journey of a star's final glow begins its gentle unfolding. The night settles around you as if it has decided to rest with you. The air grows still, and your breath finds its own slow pattern, somewhere far beyond the reach of your senses. A star is ending the way a candle ends, not in abrupt darkness, but in a soft widening of light. It's okay to drift slow. In the beginning, the star is no larger than a shimmering cloud of hydrogen drifting at a pace quieter than your pulse. Gravity gathers it grain by grain, fold by fold, until its center warms past 10 million degrees. A faint glow begins to push outward, and the star becomes a small sun in the silence of a young galaxy. You can rest now. For billions of years, it shines without hurry. Its light crosses the black distances at 3,000,000 kilometers every second, moving effortlessly through the empty dark. It travels for thousands of light years before touching anything at all. The universe is patient, and so is the star. You breathe softly, and the universe exhales through you. Inside its core atoms fuse into helium, and then into carbon building, the elements that every world one day depends on. Each transformation happens slowly, like layers of warmth turning into soft pressure. There is no rush in the life of a star. It simply continues, step by step, breath by breath, for longer than all of human time combined. You can rest now. As ages pass, the star grows heavier inside. Carbon becomes oxygen, oxygen becomes neon, and neon becomes the silent lattice of silicon and iron. Iron is the boundary. Iron steals energy instead of giving it. And when enough of it accumulates in the star's center, a mass about the size of Earth compressed into a sphere no larger than a moon, the balance shifts. The star feels its own weight in a new way. It's okay to drift. For a moment measured in fractions of a second, the core falters. Nothing dramatic yet, just a subtle stillness, like a breath held too long, and then gravity pushes inward, faster than anything can resist. The core collapses at nearly a quarter of the speed of light, folding into a sphere of neutrons so dense that a teaspoon of it would weigh 1 billion tons. Somewhere light continues to travel. When the collapse hits its limit, the core stiffens like a sudden pillar. Everything falling inwards rebounds outward at once. The shock wave rises through the star's layers, gathering heat and luminosity building toward a brightness that will outshine its entire galaxy for a brief moment in cosmic time. You can rest now. The outer layers lift away, expanding, not as an explosion, but as a soft, blooming sphere of glowing gas. It unfolds at thousands of kilometers per second, yet from afar, it looks peaceful, like a slow ripple traveling across a dark ocean. In deep space, nothing makes sound. The star's final act is silent. It's okay to drift. This is the first soft expansion of a supernova, a star returning its long-held elements back into the universe. Hydrogen and helium drift outward. Carbon, oxygen, neon, magnesium, silicon, and iron scatter into the cold. New atoms, gold, silver, iodine, uranium form. In the instant when densities become unimaginable, these atoms will one day become soil, oceans, bones, and breath. You breathe softly, and the universe exhales through you. A supernova can release as much energy in 10 seconds as our sun will emit in 10 billion years. Yet from where you rest, it feels gentle. It feels like a glow, expanding in the far reaches of time. You can rest now. The light begins its long voyage. It crosses 10 light years, then 100, then 1,000. Dust clouds bend it slightly, shifting its colors into soft reds and violets. Some photons escape untouched, carrying the memory of the star's final moment. They drift across the vast dark for millions of years. Somewhere light continues to travel. Eventually, a small portion of that ancient light reaches the outskirts of a spiral galaxy. It threads through the halo like a whisper. It slips past clusters of dark matter, weighing trillions of solar masses. It flows through the thin, warm medium scattered between stars. All the while, the universe expands gently around it. It's okay to drift. When the light finally approaches our region of space, it is weakened into a soft shimmer. The glow is faint, yet still balanced, still smooth, still carrying the signature of the star that released it. Astronomers call these signatures spectra, thin lines of color that reveal what elements the star forged in its final days. You breathe softly, and the universe exhales through you. A Type II supernova leaves behind a dense core that contracts into a neutron star. Spinning incredibly fast, sometimes hundreds of times per second, it holds a magnetic field trillions of times stronger than Earth's. Yet, in the silent space between beats, it simply persists. A small ember of dense matter suspended in a quiet cradle of expanding debris. You can rest now. Some neutron stars collapse further still, forming black holes no larger than a city. These black holes carry the last gravity of the original star. They drift through space for billions of years, shaping gas clouds, guiding orbits, bending light in gentle arcs. The remnants of a supernova do not end. They continue the story. It's okay to drift. As the expanding debris cools, it forms a nebula, a slowly widening veil of pinks, blues, and indigos. Images of these nebulae look dramatic, but in real space, they are thin, almost ghost-like, quieter than breath. Each filament stretches across light years while remaining delicate as smoke. Somewhere light continues to travel. Within the nebula, pockets of gas begin to gather. Gravity pulls them closer. Temperatures rise, and after millions of years, a new star forms in the heart of what once was a dying one. This cycle has happened countless times across the Milky Way. It will happen countless times again. You breathe softly, and the universe exhales through you. The elements in your body, the iron in your blood, the calcium in your bones, the oxygen in your lungs, were forged in stars like these. Some from quiet, stellar fusion, some from supernova shockwaves. Every breath you take is touched by the memory of a star's last light. You can rest now. The space between you and that ancient light is enormous. Yet the connection is simple, steady, and kind. A star expands fades, and drifts apart. Its atoms seed the galaxies. Its light touches the dark. And eventually, long after its glow has softened, its story becomes a whisper in your own quiet night. It's okay to drift. The expanding shell continues outward at thousands of kilometers per second, slowing only slightly as it meets interstellar gas. Over the next 100,000 years, the supernova remnant will stretch across dozens of light years. Its filaments will curve in soft arcs, shaped by magnetic fields, ancient and unseen. Dust will condense into grains smaller than smoke particles. These grains will drift with the galaxy's rotation, taking hundreds of millions of years to circle the center once. Somewhere light continues to travel, and through all this time, the universe remains calm. No storms, no rumbling, just expansion, just drift, just the soft rearrangement of matter into new forms. You breathe softly, and the universe exhales through you. A supernova can outshine its galaxy by billions of times, yet it leaves behind a quiet that lasts far longer than its moment of brilliance. The quiet is part of the story too. It is the long exhale after the bloom of light. You can rest now. Astronomers use supernovae as gentle markers of cosmic distance. Certain types, called type Ia, all reach nearly the same peak brightness. Like lanterns placed at reliable intervals across the universe, they allow us to measure how fast the cosmos expands. From these measurements, we know the universe is accelerating, carried outward by something we call dark energy. It's okay to drift. Supernova light curves the smooth rise and slow decline of brightness reveal how the star's remnants cool. In the first few days, temperatures exceed 10 billion degrees. After months, they fall to thousands. After centuries, they become the faint blue glow of ionized gas. In deep time, they fade into the quiet background of the galaxy. Somewhere, light continues to travel. When this fading light reaches Earth, it passes through the thin upper atmosphere, scattering slightly into gentle color. It touches mountain peaks, dust grains, and ocean spray before finally settling onto the world you know. Some photons even find their way through your window, soft enough not to disturb you at all. You breathe softly, and the universe exhales through you. And now, the night deepens a little more. Your breath drifts lower. Your thoughts soften into a steady hum. The star's story continues, but it moves slowly now, almost weightless, expanding across millions of years, settling into the fabric of the cosmos. You can rest now. In the quiet between stars, you are remembered. And somewhere deep within that quiet, the first soft expansion continues. We drift together now, carried by the quiet that follows a star's final glow. The night feels different once the story of a supernova has begun. It stretches gently, as if the darkness itself remembers the first widening of that ancient light. It's okay to drift. We settle deeper into this stillness, carried by the sense that everything in the universe moves softly when seen from far away. Light leaves a star as a wave, a pulse, a shimmering thread of energy, and then it travels without friction, without noise, without ever growing tired. You can rest now. The photons released in those first moments of a supernova expand outward in all directions. Some move toward empty regions where galaxies never formed, drifting for billions of years through silent voids spanning tens of millions of light years. Others pass near the bright centers of clusters, sliding between thousands of stars packed tighter than grains of sand. Every direction leads somewhere. Somewhere, light continues to travel. We follow one thin beam of that ancient glow. It moves at 3,000,000 kilometers every second. The universal speed limit steady and unchanging since the first seconds after the Big Bang. Yet from our resting place, it feels unrushed, almost leisurely, like a calm tide rolling across an infinite shoreline. It's okay to drift. As the light travels, it stretches with the expansion of the universe. Distances grow, wavelengths lengthen, blues become reds. Reds become infrared warmth. Infrared becomes microwave whispers. The universe breathes outward, and the light breathes with it. You breathe softly, and the universe exhales through you. Millions of years pass in the light's journey, though. From its perspective, no time passes at all. Photons do not feel time the way living things do. To them, the beginning and the end of their path coexist in one seamless motion. A supernova that happened in a galaxy 10 million light years away will reach another galaxy in 10 million years. Yet, the photon itself never senses the wait. You can rest now. Around the beam of light, the galaxy evolves slowly. Stars move like drifting embers in a vast and ancient wind. Gas clouds collapse into new suns. Dust rings twist into faint spirals. The remains of old stars blend into the raw material of new ones. Everything reshapes itself with patience. It's okay to drift. As the light crosses interstellar space, it passes through regions filled with atoms scattered sparsely, one particle in every cubic centimeter, yet still enough to tint and nudge the beam. This gas causes interstellar reddening, making distant supernovae look softer, warmer, more diffused. We perceive them as gentle because their long journey smooths away their sharp edges. You breathe softly, and the universe exhales through you. Occasionally, the light crosses a region dense with molecular clouds, towering structures tens of light years thick, full of hydrogen, frozen into delicate filaments. These clouds glow faintly from ultraviolet starlight, stretching in pale blues and violets. Supernova remnants often brush past these clouds, stirring them into new shapes. Gravity uses the shock wave, like a sculptor uses a soft breath. You can rest now. Across tens of millions of years, the expanding shell of supernova debris continues to cool. At first, temperatures exceed 100 million degrees, then a million, then tens of thousands. Finally, the gas glows faintly at a few hundred degrees, still hotter than any desert wind, but soft and thin in the emptiness of space. It's okay to drift. Some remnants become famous across the universe. The Crab Nebula, born from a supernova observed in the year 1054, expands at about 1500 kilometers per second. Today, it measures roughly 11 light years across, forming ghostly tendrils that twist like silk in the interstellar wind. We see its filaments because they shine in soft blues and greens, ionized by the neutron star, spinning 30 times per second at its center. You breathe softly, and the universe exhales through you. A neutron star's rotation slows over time. It emits a beam of radiation that sweeps across space like the whisper of a cosmic lighthouse. When the beam crosses Earth, we detect it as a pulse, steady as a heartbeat. These pulses can be precise to within millionths of a second rivaling atomic clocks, timekeepers made of collapsed stars. You can rest now. Far beyond the Crab Nebula, the supernova remnants of other galaxies shine with quiet elegance. Some stretch across 100 light-years, shaped by magnetic fields and stellar winds. Some remain nearly spherical, fading evenly as their energy dissipates. Some form intricate knots of dust, future seeds of planetary systems, still billions of years away from forming. It's okay to drift. As we follow the light toward Earth, we pass through the intergalactic medium, a region so thin that there is only one particle for every cubic meter. Here, light travels nearly untouched. Galaxies shrink behind us. New galaxies slide into view, their spiral arms glowing in soft gradients of star formation. Each contains hundreds of billions of suns, each with its own quiet story. Somewhere, light continues to travel. The Milky Way approaches from a distance of millions of light years. Its halo appears first, a loosely bound sphere of old stars, drifting in orbits slower than a glacier's advance. Then the bright disk glows into view. 1,000,000 light years wide, rotating once every 230 million years. Like a slow breath of creation, you breathe softly, and the universe exhales through you. As the photon nears the galactic outskirts, it passes through clouds enriched by countless supernovae that have occurred over the last 10 billion years. Each supernova added new metals, new dust, new carbon-bearing molecules. Without them, planets like Earth would never have formed. Life itself would have remained impossible. You can rest now. The photon slips into a spiral arm filled with young stars and bright nebulae. Some stars shine hot and blue, burning through their fuel in just a few million years. Others glow gently in orange and yellow, living far longer, giving their systems time to stabilize into planetary families. The arms of our galaxy are not static. They are waves of density patterns of motion that sculpt the arrangement of stars over hundreds of millions of years. It's okay to drift. Within these arms, clouds collapse into new suns every few years. Some will one day explode as supernovae themselves. Some will fade gently into white dwarfs. All will return their material to the galaxy in some final gesture of release. You breathe softly, and the universe exhales through you. The photon approaches a familiar region, the Orion Arm, a minor spiral branch where our sun resides. This neighborhood measures a few thousand light years across, filled with clusters, nebulae, and thin trails of dust. Here, supernovae have shaped the structure for millions of years. The Orion Eridanus superbubble, for example, spans nearly 1,000 light years and was carved by ancient star deaths. You can rest now. The light glides through trails of ionized hydrogen. It whispers past brown dwarfs, cometary clouds, and planets invisible from afar. It threads between the gravitational currents that fill our corner of the galaxy. Then gradually, it approaches a small yellow star, a star only 4.6 billion years old, a star we call the Sunday. It's okay to drift. From here, the photon slows its journey through the solar system. Not in speed, it still moves at light speed, but in presence becoming more noticeable as it crosses planetary orbits. Jupiter bends it minutely through gravitational lensing. Dust left by comets scatters it faintly. Finally, the photon travels inward toward a small pale blue world where oceans breathe under a thin film of atmosphere. You breathe softly, and the universe exhales through you. In the upper sky of Earth, the photon meets nitrogen and oxygen molecules. Its path shifts slightly, its color softens, its energy widens into a shade of gentle red or gold. And then, after a journey, millions of years long, the light that once bloomed from a dying star touches the surface of the world. You can rest now. The Earth absorbs some of this starlight into clouds, forests, oceans, and stone. Some reaches human eyes, where it becomes a quiet impression, a soft shimmer at the edge of night. And some threads through windows like yours, arriving quietly unnoticed, settling into the room without a sound. It's okay to drift. We rest together in the faint warmth of that ancient journey. The photon that began as the soft expansion of a star has finished its long crossing. Its life as light has ended. Its energy has become part of this moment of stillness with you. You breathe softly, and the universe exhales through you. In the quiet between stars, we are remembered. And the slow drift of light continues. The universe holds the memory of every star that has ever lived. It drifts through space the way dust settles through a quiet room, one particle at a time, soft and unhurried. The glow of an ancient supernova carries that memory forward, even after the star itself has faded into silence. It's okay to drift. In the deep expanses between galaxies, the debris of long-forgotten supernovas stretches across millions of kilometers. What remains is not violent, not harsh, but delicate, a faint lattice of atoms rearranged by pressure and time. These atoms drift in magnetic currents, unseen, forming slow spirals and loose cloud-like filaments that curve in shapes shaped only by patience. You are safe here. As each particle moves outward, it takes with it the full history of the star's life. A carbon atom remembers the moment helium fused around it. An oxygen atom remembers the heat of a collapsing core. A grain of iron remembers the instant when the star reached its final boundary. Every piece carries a story written in density, temperature, and time. You are safe and low. Astronomers describe supernova remnants through numbers and radii. But the universe doesn't use measurements. It uses motion. A gentle outward push, a slow cooling, a drifting of shape across thousands of years. A supernova remnant expands at thousands of kilometers per second, at first, then hundreds, then tens, until eventually it becomes indistinguishable from the surrounding gas. It blends into the galaxy like mist dissolving into morning air. The universe holds you. In the millions of years that follow, the remnant becomes a quiet memory woven into the interstellar medium. Dust settles. Gas spreads. Gravity begins its gathering once more. Some atoms fall into future stars. Some freeze onto dust grains, drifting through cold clouds at 10 or 20 degrees above absolute zero. Some wander alone for eons. It's okay to drift. A supernova is brief, but its influence lasts across cosmic epochs. Shockwaves from ancient explosions have shaped the Milky Way's architecture, pushing clouds outward, compressing others inward, and carving vast, bubble-like regions up to 1000 light-years across. These cavities become the birthplaces of new clusters. In each cluster, stars share a single ancestor, the supernova that sculpted the space they now occupy. You are safe here. The glow of a remnant carries information in faint lines. oxygen glowing green, hydrogen glowing red, sulfur glowing deep gold. Each color is a memory. Each memory is tied to an element, and each element will one day belong to something else. A leaf, a stone, a cloud, a bone. It's okay to drift. As the remnant expands, the neutron star at its center continues its silent rotation. Only a handful of these neutron stars emit detectable pulses, yet each one spins with incredible stability. Some rotate 716 times per second, some slow to one rotation every few seconds, but all of them carry the leftover spin of the star's core, compressed into a sphere only 20 kilometers wide. You are safe and slow. The magnetic field of a neutron star can be 1,000,000,000,000 times stronger than Earth's. Such a field shapes the flow of particles around it, creating beams of radiation that sweep through the cosmos. Yet from a distance, the effect is barely noticeable. A small flicker in the background, a quiet whisper of timed light. You are safe here. When the beam crosses Earth, we call it a pulsar. Its timing is so precise that it can rival atomic clocks. For the universe, this is a natural rhythm, a heartbeat left behind by a collapsed sunday, and in that rhythm lies a memory of the star that once shined. It's okay to drift. Some pulsars move through the galaxy at hundreds of kilometers per second. They are kicked by the asymmetry of the supernova explosion itself, like embers carried on a wind of long-gone fire. Others remain near their birthplace, hidden inside the dispersing nebula. Some become magnetars, with fields so strong they can twist their crusts into starquakes. And yet even these extreme objects exist in profound quiet. You are safe here. The universe remembers every star, not through noise, but through stillness. It remembers through the long pause between one transformation and the next. The silence after the supernova is as important as the brightness itself. You breathe softly, and the universe exhales through you. As the remnant cools, heavy elements begin to condense into grains a fraction of a micron wide. These grains, coated in ice and carbon, float through cold clouds for millions of years. They collect molecules slowly, one by one. They drift into currents, shaped by gravity and starlight. When they collide gently, they stick. When they collide too quickly, they bounce away. Building takes time. You are safe and still. Over tens of millions of years, these grains gather into clumps centimeters across. Those clumps drift into larger regions of gas, where gravity strengthens its pull. Eventually, they fall inward, toward forming stars, becoming the seeds of planets. A future world may hold oceans because a supernova once bloomed in silence. It's okay to drift. Stars themselves form from leftover dust, enriched by countless earlier supernovae. A single cloud may hold the remains of dozens of explosions. A newborn star carries the memory of every ancient star before it. Its composition reveals whether those ancestors were massive, whether their cores collapsed into neutron stars, or whether they faded gently into white dwarfs. You are safe here. The universe recycles its starlight. A supernova that occurred 10 billion years ago helped create the metals in the first rocky planets. Another supernova 5 billion years ago shaped a cloud that eventually formed the sunday. Another, much earlier, scattered the isotopes now embedded in Earth's crust. Every era of the universe holds fragments of the one before it. You are safe and slow. When astronomers observe the glow from a supernova remnant, They see not only the present, but the entire chain of events that shaped it. In the fine structure of its spectrum, they can trace temperatures from the moment of collapse. In the motion of its filaments, they can estimate the speed of the shock front. In the ratio of elements, they can deduce the mass of the original star and how long it lived. It's okay to drift. The light curves that follow smooth, rises over days. Gentle decays over months become signatures of the star's personality. A fast decline indicates a thin envelope. A slow decline suggests heavier layering. In these shapes, astronomers read the biography of a star written in brightness. You are safe here. Sometimes, far from any star-forming region, a lone remnant drifts quietly through a calm part of the galaxy. Its structure becomes wispy, less defined. Its shockwave slows to just a few kilometers per second. Its colors fade until only faint traces remain, and eventually it merges with the background gas entirely. The memory stays, but the shape dissolves. You are safe and still. All the while, the universe continues its expansion. Galaxies drift apart. Space stretches. The cosmic web forms filaments, spanning hundreds of millions of light years. And within those filaments, stars live, expand, collapse, bloom, and fade. It's okay to drift. Each supernova plays a tiny role in this vast architecture. Yet, without them, galaxies would be pale, thin, quiet. It is the heavy elements, the iron, the silicon, the oxygen, that give galaxies their richness, that give planets their solidity, that give life its chemistry. You breathe softly, and the universe exhales through you. In this way, a supernova is not an ending. It is a transition, a shift from one form into many, a turning of matter into memory, a widening of light into the fabric of space. You are safe here. And in the faint glow that remains, the universe keeps a record of everything that came before, a record written in wavelengths, densities, and drifts older than any language, a soft archive of the stars. The memory inside the glow endures. The universe arranges its dust with patience, older than every star that shines tonight. It builds slowly, one atom joining another, guided by gravity's gentle pull and the faint pressure of ancient light. This dust, drifting through the galaxy's quiet arms, becomes the raw material of worlds yet to be imagined. You are safe here. Inside the aftermath of a supernova, atoms settle into new relationships. Carbon chains link softly. Silicate grains crystallize in temperatures falling from millions of degrees to thousands. Iron condenses into metallic cores no larger than fragments of sand. Every particle forms as the remnant cools, shaping itself by laws formed in the first seconds of the universe. It's okay to drift. The architecture of stardust begins with density. In the cold regions between stars, where temperatures hover around 10 to 20 Kelvin, dust gathers in clumps. At first, the clumps are no larger than the drifting seeds of pollen, but over time, they become filaments, tens of light years long, shaped into thin strands by magnetic fields that weave silently through interstellar space. You are safe and slow. These filaments mark the first blueprints of new stars. Gravity strengthens where material collects, pulling gas inward with a patience so calm it feels like stillness. A region that once held 1 atom per cubic centimeter now holds hundreds, then thousands. Eventually, the density becomes enough to warm itself, not by friction, but by gentle compression, the universe's softest kind of heat. You are safe here. As the cloud deepens, dust absorbs starlight from nearby suns, weakening the glow and leaving a shadow behind. These shadows are the dark nebulae seen from Earth, coal-black shapes against bright star fields, hiding the early stages of star birth. Inside them, everything continues quietly. You breathe softly, and the universe exhales through you. Over millions of years, gravity turns dust grains into pebbles millimeters wide. These pebbles drift in swirling eddies, created by gas currents folding around newborn stars. Collisions occur gently. Some grains stick, some slide away, some merge into clusters, centimeters across. It's okay to drift. The architecture is delicate. Too much turbulence tears structures apart. Too little motion prevents growth. But in the right zones, near the midplanes of forming disks, the balance becomes perfect. Dust grows by contact, accumulating layer by layer. Tiny crystals from ancient supernovae become the cores of new worlds. You are safe here. Astronomers study the midplanes with submillimeter telescopes, tracing the faint heat of dust only a few tens of degrees above absolute zero. These observations reveal rings, voids, arcs, and spirals stretching across billions of kilometers. Planets carve some of these structures, gravity creates others, and sometimes the patterns are the signatures of ancient stardust, migrating inward slowly across the disk. You are safe and still. In a typical protoplanetary disk, dust spirals toward the star at a few centimeters per second, slow enough that its entire journey may take millions of years. Along the way, particles grow from millimeters to meters, and then to kilometer-wide bodies called planetesimals. These planetesimals collide, merge, fragment, reassemble, and eventually form the cores of planets. It's okay to drift. A supernova's debris plays a vital role in this architecture. Without the heavy elements released in the star's final glow, planets like Earth would never have developed iron cores or rocky surfaces. Silicates, metals, and carbon-based dust all trace their origins to stars that lived and died billions of years ago. The universe shapes these fragments with extraordinary care. You are safe here. Every planet is built from the quiet ashes of ancient suns. The poetic truth of that line runs through every system we've ever observed. Even in galaxies, tens of millions of light years away, dust clouds glow in infrared arcs, revealing that supernova debris is universal. It becomes the foundation for every structure that appears stable and solid. You are safe and slow. Within our own galaxy, more than 1% of the interstellar medium is dust. It sounds small, but that fraction determines how stars form, how light travels, how planets emerge, and how chemistry evolves. Dust cools gas clouds by radiating heat. It shields molecules from harsh ultraviolet light. It allows water to form on its surfaces. Everything delicate begins with dust. It's okay to drift. In regions like the Carina Nebula and the Eagle Nebula supernova, remnants mingle with new star-forming material. The bright pillars and towering walls of gas are carved partly by the force of past explosions, partly by the winds of young stars, and partly by the collapse of pockets dense enough to birth new suns. The architecture becomes a natural cathedral, intricate, airy, patient. You are safe here. On the smallest scales, dust grains are coated in ices, only a few molecules thick. These icy layers become laboratories for chemistry. Hydrogen atoms combine into molecular hydrogen. Oxygen binds with hydrogen to form water. Carbon chains grow into simple organic molecules. Later, when these grains fall into warmer regions, the ices sublimate and spread molecules into the gas phase. This process happens billions of times across a forming system. You are safe and still. When planets finally take shape, they inherit all these ingredients. Earth's earliest oceans likely came from icy bodies that formed beyond the sun's frost line. Its rocks formed from silicates born in ancient supernova cores. Its metals condensed in environments shaped by explosions millions of years older than the solar system itself. Everything solid traces back to stardust. It's okay to drift. Over hundreds of millions of years, dust continues to circulate. Supernovas replenish it. Stellar winds sculpt it. Galactic rotation stretches it into arms. Gravity arranges it into clusters, streams, and elongated filaments, aligned with the galaxy's magnetic field. You breathe softly, and the universe exhales through you. Some dust survives unchanged for billions of years. Meteorites found on Earth contain pre-solar grains that predate the Sun by more than 5 billion years. They hold isotopic fingerprints, revealing their origins, some from massive stars, some from red giants, some from ancient supernovae that exploded before the Milky Way finished forming its spiral arms. You are safe here. The quiet architecture continues even where no stars shine. In the halo of the galaxy, dust drifts in sparse, lonely arcs carried by tidal forces from ancient mergers. These grains reflect faint starlight, creating soft glows barely visible to even the most sensitive instruments. But they persist, held in place by the galaxy's slow, graceful motion. It's okay to drift. In the cosmic web, dust spreads across intergalactic bridges, linking distant galaxies with thin trails of enriched material. These trails trace the history of interactions that occurred billions of years ago. A collision, a merger, a tidal stream. Each event leaves dust behind, like footprints fading into the cosmic sea. You are safe and slow. Some dust will never form planets. Some will never be part of a star. Some will drift until the end of cosmic time, suspended in the expanding fabric of the universe. But even this wandering dust carries memory, a whisper of an ancient supernova, a remnant of a star's last breath. You are safe here. The architecture of stardust is a map of everything the universe has ever experienced. Every grain holds a piece of that larger story. Every element has passed through the interior of a star. Every world is built from the softened remnants of celestial fire. It's okay to drift. In the quiet between stars, matter arranges itself, not through haste, but through patience, through gentle motion, through steady drift, through the soft pull of gravity, shaping dust into the future. The quiet architecture endures, and the universe continues its long, calm work. The universe holds the echoes of supernovas long after their light has passed. These echoes drift through space as waves of energy, as vibrations in gas clouds, as quiet imprints in the magnetic lines threading the galaxy. They move gently, leaving subtle traces that last for millions of years. You are safe here. A supernova does not end when the light fades from view. Its shock wave continues outward, shaping the interstellar medium, like a soft breath shaping dust on a windowsill. The wave expands for tens of thousands of years, gradually slowing from thousands of kilometers per second to only a few. It reshapes clouds, steers, particles, and nudges entire regions of space into new patterns. It's okay to drift. The echo of the explosion becomes a shell of compressed gas stretching across dozens of light years. Inside, the shell material is thin and warm. Outside it, gas is denser and cooler. This difference becomes a boundary, a temporary outline drawn by the star's last exhale. But boundaries in space are never permanent. They dissolve, fade, and blend as the galaxy reshapes everything in its slow rotation. You are safe and slow. As the shell expands, it sweeps up dust and atoms from the surrounding medium. This process enriches the gas with heavier elements forged in the star's core. Iron mixes with hydrogen. Oxygen binds with carbon. Calcium floats outward in tiny grains. Each combination carries the memory of the temperatures and pressures that formed it. You are safe here. When a star dies, the universe breathes out a story written in elements. The quote echoes across countless observations, each confirming that stars are the authors of everything solid and complex. Every supernova writes new lines into this universal script. You are safe and still. As the shell moves outward, turbulence forms along its surface. Swirls the size of solar systems twist into rope-like structures. Shocks create ripples that compress nearby gas into denser pockets. These pockets become the seeds of clouds. The clouds become the birthplaces of new stars. It's okay to drift. Through this slow shaping, the long echo of a supernova becomes a sculptor of the galaxy's future. Waves of compression ripple outward, encouraging molecular clouds to collapse, igniting star formation across regions tens or hundreds of light years away. The star that ended its life becomes the catalyst for hundreds more. You are safe here. Some remnants create superbubbles, vast cavities carved into the galaxy's disk by multiple explosions over millions of years. These bubbles can span 1,000 light years, filled with warm, thin gas and crossed by delicate magnetic fields. The sun itself resides near the edge of one such cavity, the local bubble, shaped by supernovas that occurred long before Earth formed. You are safe and low. Inside these superbubbles, light travels with less interference. Stars appear slightly brighter. Dust levels drop. Gas becomes smoother and more transparent. These regions act as cosmic hallways where photons move freely for longer distances. You are safe here. As the echo weakens, the shockwave becomes a gentle pressure front. It no longer carves, it guides. It redirects gas softly, like wind-shaping dunes in a desert older than time. Small differences in density are amplified. Pockets cool, other pockets warm. A delicate balance emerges. It's okay to drift. In some places, the shock wave encounters dense molecular clouds. When it does, it slows, dramatically transferring momentum into the cloud's outer layers. These layers compress, and the cloud becomes more unstable. Given enough mass, gravity takes over, pulling the cloud inward, beginning the long process of star birth once more. You are safe here. Inside these compressed regions, temperatures drop to just a few Kelvin above absolute zero. Hydrogen molecules form in vast quantities. Carbon monoxide becomes a tracer that astronomers can detect through radio waves. Ammonia, formaldehyde, and other simple molecules appear. The universe quietly prepares the ingredients for complexity. You are safe and still. Even in regions where no new stars form, the echo of the supernova continues to influence the chemical landscape. Short-lived radioactive isotopes, created only in explosive environments, mix into the surrounding gas. When they decay, they release heat that warms small dust grains. These grains become miniature furnaces, speeding up chemical reactions that would otherwise take millions of years. It's okay to drift. Some of these isotopes were present in the cloud that formed the sundae. Their decay heated the early dust that formed into meteorites. This heat helped shape the earliest solids in the solar system. Tiny crystals found today inside ancient meteorite fragments. A long-vanished supernova left a fingerprint in the rocks that fell to Earth. You are safe here. Not all echoes are waves in gas. Some are gravitational, subtle shifts in the structure of a region caused by the mass lost during the explosion. When a star goes supernova, it ejects most of its mass into space, altering the balance of gravity in its neighborhood. Nearby stars drift into slightly new orbits. Clouds adjust their shapes. Patterns change slowly over millions of years. You are safe and slow. In the far future, long after the last filaments of the remnant have faded into the interstellar medium, after the last detectable radiation has quieted, after the last heavy element from that explosion has been folded into a planet or a star, or a drifting grain of dust, the gravitational shift will still remain. Its echo will never fully vanish. It's okay to drift. The universe remembers through motion. A nudge here, a shift there, a slow drift of objects across billions of kilometers. Starlight traces these motions. Dust records them. Gas clouds display them in patterns of density and glow. You are safe here. You breathe softly, and the universe exhales through you. The mirror line becomes a reminder that even the quietest patterns in space continue to move long after their origins have faded. Supernovas create echoes that last across cosmic ages. Their influence winds through time like a long, gentle vibration. You are safe and low. In some distant galaxies, astronomers observe supernova remnants so old that only faint arcs remain. Light from these arcs has traveled millions of years before reaching us. In these shapes, the echo is still visible, a curve of gas, a ribbon of dust, a mismatch in temperature where the shock passed by. The remnants speak of beginnings long gone. You are safe here, closer to home within the Milky Way. Dozens of supernova remnants expand through the arms of our spiral. Some are bright and structured. Some are faint. Some are so old that only subtle signatures remain in the way dust is arranged. But each one contributes to the galaxy's evolution. It's okay to drift. The long echo of a star's last breath becomes part of galactic ecology, a network of energy and motion connecting generations of stars. Every newborn star inherits part of that energy. Every planet carries a fragment of that matter. Every cloud has been touched by past explosions, shaped in directions chosen by events long forgotten. You are safe here. Even now, supernovas continue to occur somewhere in the universe every second. Most happen far beyond the reach of any telescope on Earth. Their light may never reach us, but their echoes still spread across the expanding cosmos. They drift into the intergalactic medium. They push matter outward. They help shape the structures that galaxies will later grow into. You are safe and still. The universe listens to these echoes, not with ears, not with sound, but with shape, with drift, with the way light bends and dust settles and gas gathers. In that quiet shaping lies the memory of every star that has ever released its final breath. It's okay to drift, and so the echo continues slow as time itself, an imprint carried across millions of years, a wave traveling through the galaxy's vast, quiet body, a reminder that endings in the universe are never sudden, never final. They become transitions written in motion. The long echo endures. The universe creates its next generation of stars in the quiet hollows left behind by the ones that came before. These hollows form when a supernova's expanding shell sweeps aside gas and dust, clearing a chamber of space millions of billions of kilometers across. Inside these delicately carved regions, the earliest seeds of starlight begin to gather. You are safe here. In the first hundreds of thousands of years after the explosion, the debris expands into a smooth, curved bubble. Its inner walls glow faintly in soft reds and blues warmed by atoms excited in the shock's passing. The bubble grows at a pace no eye could sense, but steady enough to change the structure of entire clouds. It's okay to drift. These vast, thin-walled shells become the boundaries between cold, dense gas and warm, diffuse plasma. On one side lies a compressed region where future stars will form. On the other lies the soft interior shaped by the energy of the supernova. Between them is a layer only a few light years thick, where atoms still hold the warmth of a star's final breath. You are safe and slow. As the shock wave expands, it flattens parts of the cloud into sheets. These sheets break into pillars. The pillars collapse into cores. Each core becomes denser over time, gathering mass from its surroundings through gravity's patient tug. A single collapsing region may begin as a few millionths of a solar mass, yet it continues to grow for millions of years. You are safe here. When gas cools and gravity listens, stars begin to gather. This quiet truth plays out in every nebula touched by an ancient explosion. Supernovas push the clouds, but gravity shapes them. Light illuminates them. Dust softens them. The universe works across timescales broader than imagination, building future suns from the remains of old ones. It's okay to drift. Once the compressed cores pass a certain threshold, internal pressure becomes strong enough to slow their collapse. Heat rises in the center. Hydrogen molecules bump against each other more frequently. Temperatures reach a few thousand degrees. At these levels, the chemistry of the cloud begins to glow. You are safe here. Inside these prestellar cores, dust grains absorb photons, preventing heat from escaping quickly. This process allows the temperature to rise gradually, instead of all at once. The core becomes a cradle for starlight, warm at its center, cold at its edges, balanced by physics that has never changed since the universe first formed. You are safe and still. As the core grows, denser magnetic fields thread through it like invisible lines of tension. These fields channel gas into spirals, slowing collapse in some directions and speeding it in others. The result is rotation, a gentle, persistent spin that shapes every forming star. It's okay to drift. From this spin, a disk emerges. All newborn stars have disks, wide, flat rings of gas and dust stretching billions of kilometers across. Some disks form planets. Others become empty and quiet. But each one is born from the same process, the slow collapse of gas, shaped by a supernova's distant echo. You are safe here. The star at the center continues warming. When temperatures reach about 2000 degrees Kelvin, something remarkable happens. Dust begins to evaporate in the innermost regions, leaving behind a thin cavity close to the embryo star. This cavity grows until it spans millions of kilometers. Beyond it, dust survives. Inside it, only gas remains. You are safe and low. Farther out in the disk, temperatures cool enough for water ice to form. This icy region, known as the frost line, becomes the birthplace of giant planets. Jupiter-like worlds gather mass quickly in these colder zones, while rocky planets form closer in. All of this begins with dust seeded by supernovas long past. It's okay to drift. The embryo star, now called a protostar, grows brighter with each passing century. Its surface emits infrared light. Its interior becomes more ordered. Convection stirs the hot gas upward. Magnetic fields tangle and reconnect in quiet flares. The entire object is a slow, glowing sphere of gathering heat. You are safe here. Eventually, when the core reaches around 10 million degrees, hydrogen fusion ignites. A star is born not with a burst, but with a quiet stabilization of pressure and gravity. It settles into a life that may last billions of years. At this moment, the supernova that once carved the space around it becomes the star's unseen ancestor. You are safe and still. You breathe softly, and the universe exhales through you. And in the birth of every star, there is the memory of old starlight rearranging itself. The newly formed stars in these regions often appear in clusters, their births synchronized by the same shockwave. Some are massive, shining blue and brilliant. Some are small and cool, destined to live for trillions of years. Most fall somewhere in between quiet yellow or orange suns that will eventually host planetary families. It's okay to drift. Massive stars live briefly, often only a few million years. They burn hot, stir the gas around them, and sometimes trigger more waves of star formation. In time, they too will explode, as supernovas carving new hollows, creating new dark nebulae, forging new dust. The cycle continues without hurry. You are safe here. Smaller stars remain calm and steady. Their solar winds gently push dust outward. Their light keeps surrounding disks warm. If planets eventually form, these stars may shine on them for billions of years. Every long-lived star begins as a pebble of dust, sculpted by a supernova. You are safe and slow. In regions like the Orion Nebula, this process plays out visibly. Ultraviolet light from massive stars illuminates the surrounding gas, revealing curves and filaments shaped by ancient shock waves. The nebula's brightest areas glow with the residues of stellar deaths that occurred millions of years earlier. Every glowing ridge is a reminder of that long-vanished explosion. You are safe here. As the cluster grows, older stars drift apart. Some become members of distant regions of the galaxy. Some remain in loose pairs, Some wander alone for the rest of time. Their journeys reflect the motions impressed upon them by the shape of the gas from which they formed gas, sculpted by supernovas before they existed. It's okay to drift. In the spaces between these stellar nurseries, the interstellar medium relaxes again. Temperatures drop, dust settles, magnetic fields smooth into long, quiet lines. The cavity carved by the supernova becomes less distinct. Eventually, it merges into the background of the galaxy. You are safe here. And yet the memory remains. The shape of the region, the distribution of stars, the pattern of dust, all carry echoes of the star that once bloomed in light. The architecture of tomorrow was etched into place by the death of yesterday. You are safe and still. Across millions of years, the supernova's influence becomes indistinguishable from the general motions of the galaxy. Spiral waves, gas inflows, stellar winds, gravitational tides. Everything overlaps, creating layers of history. But deep within that complexity lies the signature of a star's last exhale. It's okay to drift. And somewhere inside the quiet spaces carved by that exhale, another generation of stars continues to gather. The gentle birthplaces endure, and with them, the universe's long memory of light. The universe follows laws so gentle and steady that every star, every world, every drifting grain of dust moves in quiet agreement with them. These laws do not speak loudly. They guide through balance, through pressure, through the slow exchange of heat and motion across billions of years. You are safe here. Gravity is the first of these laws. It gathers matter calmly, one particle at a time, shaping clouds into spirals and spirals into stars. Even when a supernova reshapes a region with its brief bloom of energy, gravity remains patient, waiting for the moment when it can begin guiding matter inward. Once more, it's okay to drift. In the aftermath of any explosion, gravity works slowly. It draws the densest regions of the remnant into soft arcs, pressing them toward one another until new structures form. This motion is almost invisible on human timescales, yet across millions of years, it becomes the architecture of entire star fields. You are safe and slow. Pressure balances gravity inside every star. Deep in the center, atomic collisions push outward with a quiet insistence that keeps the star from collapsing. This balance remains precise for billions of years. A tiny increase in temperature strengthens the outward push. A tiny cooling allows gravity to narrow its grip. The star breathes in equilibrium. You are safe here. When a star stays whole, it is because two forces whisper the same truth in opposite directions. The quote describes what astronomers call hydrostatic balance. It is the calm heart of every sun that has ever shined. It is the soft law that allows starlight to persist. You are safe and still. Beyond gravity and pressure, there is the law of energy transport. Light moves outward from the star's core through convection, conduction, and radiation. In some stars, hot gas rises like a slow tide, carrying heat upward. In others, photons scatter tens of millions of times before reaching the surface, moving in zigzags that take thousands of years. It's okay to drift. These motions shape the behavior of the star's outer layers. Convection creates gentle granules the size of continents. Magnetic fields twist into loops that arc above the surface. Slow waves travel across the photosphere, shifting brightness in patterns subtle enough to be sensed from light years away. You are safe here. The law of nuclear fusion governs the star's core. When temperatures exceed 10 million degrees, hydrogen transforms into helium, releasing energy with each step. This process continues with remarkable steadiness, powering the star's light across cosmic ages. When hydrogen becomes scarce, heavier fusion begins. The star's interior adjusts slowly, layer by layer. You are safe and low. In massive stars, fusion creates elements up to iron in the final million years of life. Each stage lasts dramatically shorter than the one before. Hydrogen burning may span millions of years. Helium burning lasts hundreds of thousands. Carbon burning endures for centuries. Oxygen burns for months. Silicon burns for days. The final core forms in silence. It's okay to drift. These burn cycles are not violent beginnings, but soft transitions in the star's deep interior. The outer layers remain calm, unaware of the changes within. Light still flows across their surfaces. Winds still drift outward at steady speeds. A star nearing its end does not appear hurried. You are safe here. Neutrinos, nearly massless particles, escape the star effortlessly during these late phases. They pour out in quantities beyond comprehension, passing through entire planets as if they were not there. Trillions pass through your body every second, leaving no trace. They are silent witnesses to the shifting interior of stars. You are safe and still. In the moment before a core collapses, the laws of physics reach their most delicate balance. Gravity pulls inward with immense force. Pressure from degenerate electrons tries to hold up the core. Heat builds in the center, then falls. The balance dissolves, and the star begins its final transformation. You are safe here. You breathe softly, and the universe exhales through you. The mirror line becomes true even in these final moments of stellar change, reminding you that the universe's quiet patterns continue without disturbance. When the core collapses, the soft laws shift. Degeneracy pressure fails. Neutrons form. The core shrinks to a sphere only tens of kilometers wide. The collapse rebounds. A shockwave rises. The outer layers drift outward. A supernova blooms. It's okay to drift. Even in the explosion, the laws remain calm. Energy spreads through gas and dust. Light scatters, elements mix. Shock waves reshape the region. Nothing breaks the universe's quiet continuity. You are safe here. In the centuries that follow, the laws guide the remnant's evolution. Magnetic fields stretch as the shell expands. Particles accelerate along these fields, creating soft arcs of radio and X-ray light. Temperature gradients form in the cooler regions. Filaments twist and unwind. The remnant becomes a landscape shaped by physics older than time itself. You are safe and slow. In the 1,000-year mark, the supernova remnant resembles lace spread across the galaxy, intricate, airy, and nearly weightless. Dust condenses. In the cooler portions, heavy elements drift outward. Gas mixes with the interstellar medium. The boundaries blur. It's okay to drift. Over tens of thousands of years, the remnant merges with the surrounding gas entirely. Only slight changes in temperature and density reveal where it once existed. These subtle signatures guide astronomers in mapping the galaxy's history. The laws of the universe leave no sharp edges. Everything blends gradually. You are safe here. In the million-year timescale, the former explosion site becomes a region of potential. Gas collects slowly in arcs and folds. Dust grows in icy layers. Molecules settle into shelters created by magnetic structures. A new star-forming cloud begins to take shape. You are safe and low. Gravity now takes the lead once more. It gathers everything gently. A single fragment of dust begins a journey, lasting millions of years. A pebble forms. A core grows. A protostar ignites. The universe repeats its soft steps. It's okay to drift. The laws that govern the stars are the same laws that cradle every quiet moment. The poetry of astrophysics comes from its consistency. Nothing in the universe hurries. Nothing wastes motion. Everything unfolds in calm and patient spirals. You are safe here. Across hundreds of millions of years, the laws shape entire regions of the galaxy. Spiral arms gather material into patterns of brightness. Dark lanes of dust cut soft paths through starlight. Clusters orbit the galactic center once every 230 million years, creating a rhythm older than Earth itself. These motions, slow and predictable, form the grand choreography of the Milky Way. You are safe and still. Supernovas are only brief notes in this long cosmic song, but their influence stretches across all timescales. The laws that govern their lives and deaths also shape the motions of galaxies, the chemistry of planets, and the structure of life. It's okay to drift, and in the end, every star, every cloud, every atom follows the same soft physics, weaving itself into the universe's quiet expansion. The gentle laws endure, and the universe continues to breathe through them. The universe builds its heaviest elements in moments so brief and so compressed that no living thing could ever witness them directly. These elements form inside the collapsing core of a massive star where densities rise beyond imagination and temperatures exceed billions of degrees. Yet when we observe them from far away, their origin feels gentle, a soft bloom of material drifting outward through time. You are safe here. In the first instance of a supernova's collapse, the pressure becomes intense enough to force protons and electrons together, forming neutrons. The core becomes a sphere of nuclear matter as dense as an atomic nucleus. Around it, an ocean of particles continues to fall inward, creating a storm of neutrinos that spread out in all directions. It's okay to drift. Most of these neutrinos pass through matter unhindered. They travel outward through the collapsing layers, carrying away energy that helps the shockwave build strength. In the tiny region where they do interact, they deposit heat that pushes the shock outward again. It is inside this narrow band of motion that heavy elements first begin to form. You are safe and slow. This process is known as the R process, rapid neutron capture. Atomic nuclei absorb neutrons faster than they can decay, building heavier and heavier elements in a matter of milliseconds. The heaviest atoms in the universe, gold, platinum, uranium, all begin here in this flash of density and heat. And then as quickly as they formed, they drift outward into the expanding shell of the explosion. You are safe here. When the universe wants to create something rare, it hides the moment inside a collapsing star. This truth is written into every spectrum of every heavy element found in meteorites, planets, oceans, and living bodies. The signatures point not to gentle fusion, but to the brief extremes of a supernova. You are safe and still. As the shock wave rises through the star's outer layers, It carries these newly forged elements along with it. They begin mixed into gas, hotter than the surface of the sun by millions of degrees. As the gas expands, it cools rapidly, locking the heavy elements into fine grains of dust. These grains, though tiny, contain the rarest materials the universe can produce. It's okay to drift. When the outer layers of the star finally break free, the heavy elements scatter across interstellar space. They move at thousands of kilometers per second, spreading through the galaxy in wide arcs. Most will remain isolated for millions of years. Some will drift into molecular clouds. Some will collide with other dust grains and merge into larger fragments. Every piece holds the memory of the supernova that created it. You are safe here. Over time, the heavy elements begin to bond with surrounding atoms. Gold binds with sulfur. Platinum mixes with carbon. Rare earth elements form crystalline seeds within cooling dust. These tiny particles drift in magnetic currents, spiraling slowly through the galaxy's broad arms. You are safe and low. A single supernova can create several Earth masses of heavy elements, but spread across a galaxy of hundreds of billions of stars, the concentration remains delicate and low. This is why gold and platinum are rare in planetary crusts. Their scarcity tells the story of their violent birth and their long journey across cosmic distances. It's okay to drift. As the debris cools, the atoms settle into more stable configurations. Isotopes decay. Electrons find their long-term orbits. The energy of the supernova softens into infrared warmth. What remains is a cloud rich with the most intricate building blocks the universe has ever crafted. You are safe here. In the darkest regions of interstellar space, these atoms become part of the delicate chemistry of molecular clouds. They settle onto icy dust grains, where simple molecules form and dissolve in cycles that last millions of years. Heavy elements help shape this chemistry, allowing reactions to occur that otherwise would not. You are safe and still. You breathe softly, and the universe exhales through you. The mirror line becomes a reminder that even the rarest materials in your own body were once born in silence and heat inside ancient stars. And in these quiet clouds, far from the explosion that forged them, the heavy elements begin their journey toward new worlds. In the cold silence of molecular clouds, heavy elements settle like ancient seeds waiting for the right moment to take shape. They drift slowly, caught in gentle eddies of gas, moving no faster than a walking pace. They cling to dust grains coated in thin layers of ice, forming the smallest architectures of future worlds. You are safe here. These grains gather in the heart of dense clouds, where starlight struggles to penetrate. Temperatures fall to 10 or 15 Kelvin. In this darkness, chemistry grows more delicate, guided by heavy atoms that act as catalysts for forming complex molecules. Reactions that would take eons in warm gas occur in a fraction of the time on these chilled surfaces. It's okay to drift. Iron clusters together, first anchoring other atoms to its surface. Gold and platinum align into microscopic crystal lattices. Rare earth elements merge with silicates forming grains, only a few nanometers wide. Most of these structures remain small, but some accumulate layers over millions of years, growing into dust large enough to influence the texture of the surrounding cloud. You are safe and slow. When dust remembers a star, the universe remembers how to build. The poetic truth resonates in every grain enriched by heavy elements. Each particle holds the residue of nuclear reactions that occurred in the final instance of stellar collapse. These memories guide the chemistry of future nebulae shaping pathways toward complexity. You are safe here. As the cloud slowly moves through the galaxy, passing through spiral arms and drifting past clusters of young stars, ultraviolet light begins to strike its surface. This light triggers photochemical reactions, releasing water vapor, carbon monoxide, and organic molecules into the gas. The cloud becomes a living archive of chemistry, each reaction adding nuance to its future. It's okay to drift. At some point, gravity tightens its hold on part of the cloud. Gas collapses inward. Dust follows. Temperatures rise. And as the cloud compresses into a nascent, star-forming region, the heavy elements become concentrated in the inner layers of its swirling disk. These materials, iron, nickel, platinum rare isotopes, drift toward the midplane, settling into a thin band, billions of kilometers wide. You are safe here. Inside that band, particles collide with gentle persistence. A gold-bearing grain meets a pebble of silicate. A shock of contact fuses them. A fragment of uranium becomes embedded in a larger seed. A cluster of iron forms the growing core of what will eventually be a solid world. You are safe and still. Over thousands of years, these grains grow into clumps meters wide. Over millions of years, they become planetesimals, hundreds of kilometers across. Inside them, heavy elements sink to the center, creating metallic cores heated by radioactive decay. This internal warmth becomes a subtle furnace that shapes their geology long before they become full planets. It's okay to drift. Some of these planetesimals collide and merge. Others shatter, scattering heavy elements across the disk. Still others spiral inward toward the forming star, contributing trace metals to its atmosphere. But in every case, the rare atoms forged in a supernova find new homes. Nothing is wasted. You are safe here. As planets emerge, their composition reflects the history embedded in the cloud. A rocky planet develops an iron core, almost entirely forged in ancient supernovas. Its crust includes elements like thorium and uranium that continue to heat the mantle for billions of years. Its surface gains heavy metals that will eventually cycle through oceans, stones, and living systems. You are safe and low. On worlds where conditions allow these heavy elements become tools for more intricate chemistry. Iron binds with oxygen in blood-like molecules. Manganese catalyzes reactions. Calcium made in dying stars strengthens bones. Iodine helps regulate life's rhythms. Every element, heavier than iron, carries the signature of a supernova's brief bloom. You are safe here. You breathe softly, and the universe exhales through you. The mirror line returns, because the heavy elements within your own body, the ones allowing your breath, your heartbeat, your quiet thoughts, all trace their origin to these ancient processes. The universe holds its memory through you. In the vastness of time, supernova elements shape galaxies. They enrich halos. They seed spiral arms. They form the metallicity gradients. Astronomers map across billions of stars. A galaxy, rich in heavy elements, glows differently, forming worlds more readily building complexity with every new generation. It's okay to drift. Even in the far future, when galaxies evolve into quieter forms, the heavy elements forged today will still drift through cosmic space. They may gather into new stars. They may fall onto cooling white dwarfs. They may become part of planets orbiting suns, yet unborn. Their journey is slow and endless. You are safe here. Heavy elements are the lasting legacy of supernovas. They do not fade. They do not disappear. They continue their soft migration through the universe, a silent bloom spreading across billions of years. And in that bloom, the universe remembers its own history in the language of matter. The universe carries the light of old supernovas across distances so vast that their glow becomes a soft echo by the time it reaches new worlds. This light drifts through space quietly, its brightness fading into warm hues, its energy stretching into gentler wavelengths. It becomes a memory more than a signal, a whisper of what once unfolded in brilliance. You are safe here. When a supernova first blooms, its light rises in a smooth curve, brightening over days until it shines billions of times more intensely than the star that produced it. But even at its peak, the universe handles this brightness with calm. There is no sound, no shock, no disturbance. Only a soft flood of photons traveling outward in every direction. It's okay to drift. These photons leave the remnant with clarity. They carry spectral lines that reveal temperatures of tens of thousands of degrees. They hold chemical signatures of hydrogen, helium, oxygen, silicon, and iron. They trace the motion of the expanding shell. Every photon becomes a small messenger of information, moving through deep space for as long as the universe allows. You are safe and slow. As the light travels, it stretches with cosmic expansion. Where it once glowed blue and intense, it now drifts into soft reds and warm infrared. This reddening is not loss, but gentleness, the universe calming the light as it moves through widening space. You breathe softly, and the universe exhales through you. Over millions of years, some of this ancient light will pass through clouds of dust. The grains scatter shorter wavelengths, letting only the warm colors continue forward. What reaches distant eyes becomes a dim amber glow, a reminder that light remembers everything it touches. You are safe here. Other photons slip through regions nearly empty of matter. In these cosmic voids, they travel almost unchanged for tens of millions of light years. Their paths remain straight and silent, unbent by gravity, unblurred by dust. This clarity allows astronomers to read the story of a supernova long after its debris has cooled into invisible strands. It's okay to drift. When light travels far, it carries the shape of the universe with it. This poetic truth becomes practical science. By tracing the faint curves in ancient supernova light, astronomers learned that the universe is expanding faster over time, a discovery that revealed the presence of dark energy, the quiet force stretching the cosmos. You are safe and still. Some photons encounter galaxies along their journey. They slip through halos filled with sparse ancient stars. They pass through disks shaped by billions of years of rotation. They glide along gravitational fields that bend their path slightly, focusing them like soft cosmic lenses. The universe curves the light, gently preserving the story it carries. You are safe here. When the ancient light finally nears a region rich with new stars, its glow falls into the background of their brilliance. But even then, the photons persist. Some strike dust grains and warm them faintly. Some bounce off surfaces of newly formed worlds. Some drift into atmospheres where molecules scatter them into sky-colored hues. All of it is the same light older than memory. It's okay to drift. In the Milky Way, the ancient light must pass through spiral arms filled with gas and dust. Here, The brightness softens. The glow becomes faint and smooth, filtered through clouds that were themselves shaped by supernovas long past. The galaxy treats the light tenderly, folding it into its luminous tapestry. You are safe here. Closer to home, the ancient photons mingle with starlight from nearby suns. They add warmth to the night sky, subtle enough to go unnoticed, yet steady enough to be measurable. Their presence becomes part of the cosmic background. The soft glow astronomers call extragalactic light. You are safe and low. Some photons continue their journey toward planetary systems. They slip through asteroid belts. They cross cometary clouds. Eventually, a small fraction arrives at a world with oceans, mountains, and a thin layer of atmosphere. Here, the light bends once more, softened by air, scattered into gentle gradients of red and gold. It's okay to drift. On such a world, a tiny part of this ancient glow may reach a resting place, the surface of a lake, the leaves of a forest, the window of a quiet room. Its warmth is subtle, almost unnoticeable, but it is real. It is the final step in a journey millions of years long. You are safe here. Some of the light is absorbed by molecules that convert its energy into warmth. Some reflects into the night sky, returning upward to mingle with the stars. Some enters the eyes of beings capable of sensing faint glimmers, becoming part of their inner world. You breathe softly, and the universe exhales through you. And in that moment, ancient light finds its home in the quiet of a single breath. The return of this light continues softly and endlessly across the fabric of cosmic time. The universe allows ancient light to drift back into the places shaped by the very stars that released it. This return is not a loop in space, but a continuity, the slow reuniting of energy with matter that once shared the same origin. Every photon that survives the long voyage becomes part of a gentle circulation of brightness. You are safe here. As ancient light filters into planetary atmospheres, it blends with the softer emissions of younger stars. Some photons shift into longer wavelengths, becoming warmth rather than color. Others scatter into faint glows that enrich night skies with tones too subtle for human senses. This softening is the universe's way of letting brightness become calm. It's okay to drift. When the light touches a world rich in dust and moisture, it dances across clouds and surfaces. Ice crystals refract it. Water absorbs it. Carbon-rich soils scatter it. The glow becomes part of weather, part of reflection, part of the quiet interplay between light and matter that shapes the rhythms of the planet. You are safe and slow. Some photons descend into oceans. They lose their energy, gradually warming the upper layers by fractions of a degree. Even this small influence carries the story of a star long gone, its brilliance transformed into softness inside a living world's waters. You breathe softly, and the universe exhales through you. In certain rare moments, ancient light meets the elements forged in the same supernova, gold molecules resting in stone, iron flowing through the blood of living beings, calcium lit within shells and bones. The reunion is silent, but it completes a journey across cosmic distances. The universe brings its scattered origins back into contact. You are safe here. Other photons never reach a surface. They remain suspended in atmospheres scattered between molecules of nitrogen and oxygen. They ride the currents of warm air rising. They drift into cooler layers descending. They merge into the diffuse glow that fills the sky long after the sun has set. It's okay to drift. When old light becomes warmth, the universe remembers how gentle creation can be. This truth plays out across landscapes where the glow of distant supernovas adds softness to the night. It does not brighten the world. It steadies it, deepening shadows and calming edges. You are safe and still. Some ancient light returns not to planets, but to dust clouds forming new stars. There, photons deposit warmth into cold ices, helping molecules rearrange into more complex patterns. They trigger reactions that seed the chemistry of future worlds. The light that once left a dying star now guides the first steps of another's birth. You are safe here. In regions where star formation is active, ancient photons slip through the edges of bright nebulae. They pass the curved outlines of pillars shaped by winds and shock waves. They illuminate thin surfaces of gas, making them glimmer like faint curtains of color. The glow becomes part of the nebula's quiet breath. It's okay to drift. Closer to dense cores, the light fades entirely. The dust becomes too thick, the molecules too cold. But even then, the warmth carried by absorbed photons influences the collapse of these forming stars. Every degree matters. Every soft infusion of energy shifts the timeline of birth. You are safe and low. In the oldest clusters of the galaxy, where stars have long since exhausted their fuel, ancient light moves freely between red giants and cooling white dwarfs. Its presence adds a warm sheen to the cluster's halo, blending with the faint blue of scattered starlight. Even in these ancient places, light remains gentle, still carrying echoes of events millions of years gone. You are safe here. Some photons complete their journey by entering the eyes of beings capable of recognizing their glow, not through sharp vision, not through measurement, but through a sense that the night sky holds stories older than time as we understand it. Light touches perception, shaping awareness, steadying thought. You breathe softly, and the universe exhales through you. And in that perception, the photon's journey finds meaning, a quiet return to consciousness, memory, and rest. The ancient light becomes part of the inner universe, calming the spaces where thoughts drift and soften. It becomes a guide into stillness, a companion in the quiet, a final echo settling gently into a single breath. The return of ancient light continues soft and unbroken as long as stars bloom and fade across the cosmic sea. The universe settles into its quiet shape after the long journeys of light, dust, and memory have unfolded. The stars that once burned with fierce brilliance now fade gently into the calm backdrop of the galaxy. Every remnant, every drifting atom, every softened photon becomes part of a broader stillness. You are safe here. The great arcs of ancient supernova remnants stretch thin across space, their filaments no longer driven by powerful shock waves, but carried instead by the slow tides of the interstellar medium. Temperatures fall until the gas glows only faintly in radio wavelengths. Dust cools to just a few degrees above absolute zero. Everything breathes slower now. You are safe and slow. The neutron star at the core of the explosion continues its rotation, but even that rotation gradually dims. Its pulses become softer, losing strength in quiet intervals, drifting towards silence. The magnetic field weakens over millions of years. The lighthouse beam fades. Only a faint whisper of X-ray light remains. It's okay to drift. Farther out where the debris has merged with the surrounding gas, The last traces of the explosion dissolve into broader galactic currents. Dust no longer remembers which particles were forged in ancient stars and which belonged to younger ones. The interstellar medium becomes a gentle ocean where everything blends into one vast continuum. You breathe softly, and the universe exhales through you. As the Milky Way rotates one full turn every 230 million years, the remnants of countless supernovas stretch and fold into its structure. Some become part of sweeping spiral arms. Some become part of dim inter-arm regions. Some drift into the halo, carried by slow gravitational tides. Every particle finds its place without urgency. You are safe here. The oldest light continues its silent journey. It threads through the galaxy like thin strands of memory. Cosmic dust scatters the harshness away, letting only the softest glow remain. By the time it reaches new worlds, it has become gentle, unthreatening, peaceful. It is the perfect end to a story that began in brilliance. You are safe and low. When stars complete their lives, the universe remembers them in the quiet. This poetic truth forms the final layer of supernova science. The fading afterglow, the cooling debris, the calm return of matter to the galaxy, all become part of a tapestry built on patience rather than force. It's okay to drift. The energy, once released in fire, now settles into long wavelengths of warmth. Infrared glows fade into microwaves. Microwaves fade into subtle fluctuations in the cosmic background. Eventually, even these traces stretch into wavelengths too long for any instrument to detect. Yet the memory remains in the shape of the galaxy itself. You are safe here. Now the universe begins its transition toward kinesthetic quiet, a deeper stillness shaped not by light, but by motion, softening by drift, slowing by vibration, rounding into calm arcs. Stars move through the galaxy at hundreds of kilometers per second, but from the quiet vantage of deep time, their motions feel like slow tides, unhurried and harmonious. You are safe and still. Planets orbit their stars with perfect regularity. Moons drift in long, stable paths. Asteroids circle in quiet belts. All of them carry heavy elements forged in supernovas long ago. Their motions are slow, repetitive, comforting the mechanical heartbeat of a universe shaped by starlight and time. It's okay to drift. Inside planetary interiors, the heavy elements continue their slow, ancient work. Iron cools, nickel contracts, radioactive isotopes decay with soft persistence, releasing warmth that moves through stone. Mountains shift over millions of years. Oceans rise and fall. Continents drift like clouds made of earth. You are safe here. The universe cares for its own history with gentle hands. It preserves the shapes left behind by long extinct stars. It carries their atoms into soil, rivers, and breath. It lets their light soften into memory. The cosmos holds its past, the way a forest holds ash from old fires, using it to nurture what comes next. You breathe softly, and the universe exhales through you. Somewhere in the galaxy, a new star forms from the dust enriched by dozens of ancient explosions. Its disk spins in slow circles. Pebbles collide gently. Planets gather over millions of years. The cycle repeats with the same calm rhythm it has followed for more than 13 billion years. It's okay to drift. The young star grows brighter. Its planets cool into long-lasting worlds. Its moons settle into steady orbits. Its dust clouds clear. And when its light spreads across the galaxy, it carries the signatures of every supernova that contributed to its birth. You are safe here. The memory of ancient stars becomes the structure of new ones. The glow becomes warmth. The warmth becomes chemistry. The chemistry becomes the quiet architecture of life and matter. Everything that exists now is woven from the remains of what came before. You are safe and slow. In time, even the newest stars will fade and return their matter to the galaxy. White dwarfs cool into blackened spheres. Neutron stars lose their spin and settle into silence. Black holes drift into the outer regions, carrying gravity with them like invisible anchors. Yet, none of this feels like loss. The universe treats each ending as a soft transition. It's okay to drift. Galaxies collide over billions of years. Their stars pass through each other like ghosts, reshaping the grand structure without disturbing the deep quiet. Dust clouds merge. New starbursts ignite in glowing arcs. Supernovas follow, and the cycle continues, steady and slow. You are safe here. Even when galaxies fade long into the distant future, their dust will continue its slow drift through expanding space. Atoms will remain. Elements will persist. Memory will not vanish. It will simply stretch into quieter, softer forms. You breathe softly, and the universe exhales through you. This is the final drift, the moment where all motion slows into the rhythm of cosmic rest. Light softens, heat fades, gravity stretches into the horizon. The universe sinks into deeper, quiet, but it never becomes empty. It carries every story in its silence. You are safe and still. The last echoes of ancient supernovas settle into place. What was once brilliant becomes gentle. What was once powerful becomes calm. What was once loud becomes a whisper, woven into time itself. It's okay to drift. And now, as the universe moves into its quietest phase, something subtle happens. The same elements forged in distant stars, scattered by explosions carried by light, gathered into worlds, now rest in your breath, your bones, your quiet pulse. You are made of this long journey. You are made of calm starlight. You are made of endings that became beginnings. You are safe here. The universe has traveled far to reach this stillness with you. You breathe in, the galaxy drifts. You breathe out, light settles into memory. In the quiet between stars, you are remembered. And the final drift into stillness continues. The universe grows quieter, now settling around you like a soft horizon of starlight. Every echo, every drift, every memory of ancient stars slows into a gentle hum beneath your breath. You are safe here. The last traces of supernova glow fold into the dark, becoming warmth instead of brightness. The heavy elements sink into stillness. The dust settles, and the long arc of cosmic motion softens into something steady and kind. It's okay to drift. Your breath moves low and slow, matching the rhythm of a galaxy rotating once every 230 million years. A motion so calm it feels like rest itself. Your body follows that rhythm. Your thoughts follow that rhythm. Everything opens into quiet. You are safe and low. You breathe softly, and the universe exhales through you. The mirror line returns one last time, settling into the quiet center of your awareness. Light warm, steady, you are safe here. In the silence that follows, stars continue their ancient cycles, Dust continues its slow drift. Light continues its long journey, not to wake you, but to stay with you as a gentle presence. You are held by the same laws that cradle galaxies. You are made of the same elements that bloom in supernovas, and the universe settles with you now. Light still travels, a final shimmer, folding into the dark. The universe breathes through you, a soft pulse, becoming slower and slower. You are home. You can rest now. You are home. You can rest now.